Morning guys, today we're going to take a look at page 8 of the Unit 9 Classwork packet. The topic for today is trigonometry, which kind of gets a bad rap a lot of times because people are like, oh my god, trigonometry is the hardest thing ever. But it's actually one of the easier and, for some people, actually more enjoyable topics that we cover this year. First things first, what is trigonometry? Trigonometry is the use of ratios. Let me say that again. It's the use of ratios derived from similar right triangles. The use of ratios derived from similar right triangles in order to solve for sides. Let me say that whole thing again. The use of ratios derived from similar right triangles to solve for unknown sides. All right. Now, just to give you an idea of what the heck I'm talking about here. Oh gosh, this marker is dead. Seems to be a common theme. All right, just to give you guys an idea of what I'm talking about. All right, so here's a triangle. And here's a bigger triangle. Okay. Now, notice something important. These two triangles are, well, we would say similar. Okay, one's kind of like a bigger version of the other. And when we're dealing with this in trigonometry, what we're concerned with is the fact that we know that they're similar by angle similarity. In other words, because all the triangles that we're going to be dealing with are right triangles, we automatically know that we have these 90-degree angles in common, right? And then in the vast majority of problems, they're also going to give us one of the acute angles. In this case, I've just chosen 30, right? Because it's one of the more common ones we're going to see. And notice that that alone is enough to prove that these two triangles are similar by angle similarity, and thus that means that their corresponding sides are proportional. So trigonometry is really just a way to piggyback on the fact that when we're dealing with right triangles in which we happen to know one of the acute angles, we're using similarity to our advantage, okay? So that's a little bit more than you guys need to know for the time being, but I want to make sure you understand that big idea. Trigonometry comes from similarity. The reason that trigonometry works is because when I have two triangles that are similar, I know that their corresponding sides are proportional. Now, let's get down to the nitty-gritty. When we're talking about trigonometry, we said that we're talking about ratios, okay? Now, ratios means fractions, right? Something over something. And there are three trigonometric ratios that we need to know. And let's go over them each in turn. All right, so this is A, B, and C. Okay, so let's say, for argument's sake, that we're going to be using this. We're going to start off with A as the angle we're talking about, okay? The sine of A, here's what I mean, the sine, which is sometimes abbreviated with SIN, it's not pronounced sin, it's still pronounced sine, that would equal what's called the opposite over the hypotenuse. Opposite over hypotenuse. So let me show exactly what I mean by that. Opposite just means the side that's across from it. So if I wanted to find the sine of A, which means the sine of angle A, all I would do is I would look at which one's across from it, that's little a, and which one is the hypotenuse, that would be C. So the sine of A would actually just be A over C, little a over little c. Now, if instead I chose to do the sine of angle B, well, that's just going to change which one's the opposite, right? Which one is across from angle B? Well, that would be little b. So the sine of angle B would just be little b, opposite, over the hypotenuse, which is C. For those who forgot, the way we know which one's the hypotenuse is it's always across from the right angle. Notice how the right angle here opens up to C. So the C would be the hypotenuse, okay? By contrast, the cosine ratio, cosine, which is abbreviated cosine, that's represented by what's called the adjacent over the hypotenuse. A lot of people get thrown by the word adjacent. Adjacent just means the side that's right next to it. So if I want to find out what the cosine ratio would be for, let's say, angle A, okay, so I'm not looking for the opposite. I'm looking for the one right next to it. Now it looks like there are two that are right next to it, right? B and C, but C is already taken because it's the hypotenuse. So B would be the adjacent. So I would say that the cosine of A equals little b over little c. And if I wanted to kind of switch my perspective, so now I'm looking over here, well, which one's the adjacent? Which side is right next to angle B? Again, it may look like we have two options because both C and A are next to it, but C's already taken as the hypotenuse, so A would be my adjacent. So the cosine of B would be little a over little c. Last but not least, the tangent ratio. Okay, let me keep this consistent. Let's do it in pink. The tangent ratio, which is abbreviated as tan, T-A-N, that represents the opposite over the adjacent. All right, in a future course like pre-calculus, you'll learn that the tangent is really just the sine over the cosine, but we'll talk about that later, if at all, okay? All right, so in this case, let's say we're dealing with the tangent of A. So A is the angle I'm talking about, okay? Now, the tangent would be the opposite over the adjacent. Okay, so which one's opposite? Let's draw an arrow. Which one's across? That's A. Which one is right next to it? That would be little b. So the tangent of A is actually just little a over little b. Similarly, if I try to do the tangent of B, let's switch our perspective. Okay, let's switch our perspective for a second. Which one is opposite? Which one's right across from angle B? That would be little b, right? And which one is right next to it? Which one's adjacent? Well, it's not C because C's the hypotenuse, so it's got to be little a. So I could say then that the tangent of B is simply little b over little a. Now, there's actually a pretty easy way to remember this, okay? And it's by using the acronym SOHCAHTOA, all right? It's kind of a fancy way of saying a set of abbreviations that stand for something. So let's go through and fill this in. This is where it says remember in big letters, okay? SOHCAHTOA. Okay, so what the heck does SOHCAHTOA actually mean? SOHCAHTOA means that the sine, I'm abbreviating it here as sin, S-I-N, but it's actually pronounced sine, is the opposite over the hypotenuse. The cosine equals the adjacent over the hypotenuse. And the tangent equals the opposite over the adjacent. And notice here, SOHCAHTOA. All right, so that's just kind of like an acronym that helps you guys remember the ratios so that on an exam like the PSAT or SAT where they don't actually give those to you, you can memorize them pretty easily without doing too much mental work. In the next video, we'll take a look at a few examples of how to actually calculate the trigonometric ratios.